Hello and welcome to the final office hours. Oops, whoa. Sorry, we're running a little bit behind schedule today. This is our final office hours of the semester, and actually the last time we're meeting before the final exam. At this point in time, everybody is done taking exam 3. I haven't looked at it yet. Okay. Oh, Gregory gave me a heart attack. You said you haven't seen anything about the final exam. I thought you said the exam, and I was thinking exam 3, and I was like, holy moly, it already closed. You gave me a heart attack. Okay, yes. Gregory. It is all the final exam. It will be all multiple choice. I guess I can share with you what I know about it so far. So our final. Well, here, hang on one second. Hang on, I gotta find my. You gave me a small heart attack. I was like, seriously. I was worried that you had missed the exam. I'm so relieved that is not the case. Let's see. Okay, hang on. There we go. Okay, sorry, I just had to toggle my my color swatches. Okay, so so for the final exam, here's what I know, and I can okay, here, hang on one second. I can hear my kids fighting in the other room. Alrighty, I am back. Today my wife is working, so I'm sneaking off to do office hours while the baby's asleep. But unfortunately, there's still 2 other children who are conscious and can fight with each other in the absence of a parent. Hopefully it won't be too bad today. Okay, so I was about to talk about the final exam. Raj, that is correct. There is no lecture on Monday. So we have no further classes after this moment in time. Next week is finals week, and finals week there are no classes, lecture, or lab. It's just the exam. So, the first off, we will be taking the final during our scheduled time slots. So let me just look this up to make sure that I have things right. FLC. Okay. Let me check out our final exam schedule. So, let's see. Our class starts at 11:30 and is Monday, Wednesday. Okay, so our final exam will be during the scheduled time slot. It will be held on Wednesday, May 20th. From 11 a.m. to 12:50 p.m. And again, those of you who qualify for additional time through DSPS will have your accommodations built into your timer. So the start time will be the same for everybody, but those of you with time qualifications will it'll go longer than 12:50. Okay, so yeah, so Vraj, it's actually, and final schedule is always weird. Sometimes it's at the scheduled class time, sometimes it's not. So our final actually starts at 11 and goes to 1 because it is a 2-hour final. So you can see here that we're dealing with 1 hour and 50 minutes. So it's going to be longer than a normal exam. That's consistent with it being the final. On the final, all questions are multiple choice. All right, so 100% of them are multiple choice. Salvish, great question. Yeah, Raj, good thing you checked. And again, I'm going to be posting to Canvas about this with all the details. Right now, I only have some because I'm not completely finished writing. And so, Salvish, good to see you, by the way. The answer to your question, how many problems are going to be on the exam? I'm not 100% sure, but I can say that there will be between 60 and 70 problems. Now, before your heart drops into your shoes at that, again, remember these are not only are these multiple choice problems, but the multiple choice questions are going to be so I'm currently in the process of writing. Oops. I'm currently in the process of writing the final exam. Doing it between changing diapers and whatnot. But the questions are patterned after your ACS homework. You'll recall, if you can remember the beginning of the semester, I told you that the reason why I assigned the ACS homework is because I give the ACS final. Under normal circumstances, I give the ACS final. And so I assign homework from the ACS study guide so that everybody kind of gets used to the format that the final exam takes. And because of everything moving to online instruction, we're not able to give the actual ACS final because again it's a sealed exam, so and there's no digital copies of it available anywhere. So I'm having to write my own exam, but because I told you that the ACS homework was there to help you prepare for the problem, because I told you that the ACS homework was there to help you prepare for the final, I wanted to on that pledge, and so not to defeat the purpose of the ACS homework. So the final that I'm writing, I'm drawing direct inspiration from that ACS study guide. I'm looking at the types of problems that they include, and I'm patterning the problems after that kind of style and that form. So when you see 60 to 70 problems, they're not like 60 to 70 multiple part free answer problems like the kind that I write for my tests. I'm writing these problems, I'm kind of in the spirit and in the style of the ACS homework that I've been assigning. So each one of them are smaller and more doable. So, and again, I haven't figured out exactly how many problems are on the test, as you can see. But if we're between 60 and 70, then you're looking at let's see here. You're looking at about 1.7, depending upon how long it is, to 2 minutes per problem. That's the time scale we're looking at. Okay, Gregory, you have a question. Also, on exam 3, you had to draw 5 Lewis structures for C4H10. Should it have a negative charge? Gregory. Let me see. There should have been no negative charge. So yeah, on your version of the exam, you had C4H10. There should have been no negative charge in that Lewis structure. Right? Yes. No negative charge. Let's see. So, what do I have here? The date, question style, a range of problem type, and then that the questions are patterned off the ACS homework. I actually do have a little more. 31 valence electrons. Actually, let me think about that. 10. Actually, C4H. Oh, yeah. Winnie, no negative charge as well. Oh, sorry, no positive charge as well. Or I should say no positive charge either. Yeah, let's do this. Here. This is what office hours are for, right? So let's take a look. So for C4H10. C4H10. Oh. Hold up. I thought we were talking about... Here, hang on. I'm gonna pull up. Gotcha. Okay. Okay, hang on. Let me pull up the exam. It's possible that there was a typo, which is good news. Good news for all of you, if there was, because what up, Zulai? Let's see here. Do. We've got to find, because there are several versions of the test. I have to find the one that you had. Okay, it's not that one. There is, Sulai, there is. The take-home exam is worth 60, but there were 70 points available. So there are 10 points of extra credit built in on the take-home. Let's see. Oh, stupid me. All right. So on one of the exams, I messed up. On one of the exams, I messed up. Let me see. Let me check the last version. Okay, so two out of the 3 versions of the test were fine. If you had the version, totally, Zulai. Oops, hey. Let's get rid of that. All right, so if you had the version of the test that had C4H10 nitrogen, all right, this had a typo, which I will take into account while grading. Oh yeah, well, there's more than one test that has this problem on it, Viraj. So the written this time around with the written exams, there were 3 different versions, one of which has C4H10N. This is a typo. It should have been C4H11N. All right, and I'm gonna take this into account while grading, because as the problem. Yeah, totally. Wait, the typo, Winnie, is the hydrogen count. All right, the hydrogen count. So, and the reason why this is a problem, the reason why this one is a problem, is is with the current electron count, you cannot complete everything's octet. Which you had, yeah, totally. So you had no way of knowing how to fix it. So how I'm gonna grade this one. If you had this version of it, it's gonna be graded a little more gently than normal. I'm basically gonna look at it and say, were you able to, with the number of atoms given, draw 5 different molecules, but there's that problem of you wouldn't have been able to solve the octet rule, so it's going to get a softer treatment than if the typo hadn't been there. That being said, what I'm going to do is I'm going to take the correct structure here and show you, if you guys want to see it, how to work this problem. And how to come up with all of the structural isomers. Right, so for C4H11, and we do our total electron count. Carbon brings 4 valence electrons to the table, and we have 4 of them here, so that's 16. We have 11 hydrogens, so that brings 11 valence electrons, and then our 1 nitrogen has 5. All right, so 16 plus 16 is 32. Is our total electron count. And we don't have a central atom, really, for this molecule. But if you attach all our carbons together and that nitrogen, we'll spend 8 electrons. Attaching our, hang on. So that would leave us with 24. We've got 24 electrons. Attaching our 11 hydrogens, we'll take 22. Right, because 22 electrons, because we're making 11 bonds. 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh, here, 20, 22. I forgot to write in my last 2 because we've got 11 H's. Sulai, that is correct. That is correct. C4H10O is not a typo. So this leaves us with 2 electrons. And you see, without that 11th H, we would just have 1 electron here. And so with these 2 electrons, we're going to complete nitrogen's octet. Leaving us with no valence electrons. Now, this is 1. And we need to come up with 5. 5 structures. All right, so here's one of them. Another way we could do this. Oh, yeah. yeah. Do not sweat it. Okay, So here's the first example for this one. Now, with structural isomers, they're compounds that have the same chemical formula, but they have a different connectivity, right? So I'm going to open a new slide and just redraw this guy. So you can see here that in this first structure, we've got everything kind of in a line. You'll see why doing this problem will teach you why organic chemists hate drawing hydrogen, because it takes up so much dang time. So you can see in this first structure that we've drawn, labeling this one number 1 again, we've got 4 carbons in a line and then nitrogen on the end. Well, one way to generate a new structure is to, instead of having 4 carbons in a row, what if we had just 3 carbons, then a nitrogen, and then another carbon, kind of put the carbon on the other side. And this would give us a second unique structure. And then again, writing out our 11 H's as patiently as we can. All right, this would be a second unique structure. All right, and all this is it's a variation on a theme. We're just trying to find different ways to connect these things. Let's see. I'm going to make a study guide topics we should for the final exam, or... okay, Sulai, that is a great question. Great question. I will be able to, let's see here. Today I can give you a rough breakdown of what topics will be on the final exam. I'm still let's see, hang on. So Sulai, I can give you a rough breakdown. I'm in the process of writing it. I haven't finished, and so I know kind of in general what portion of the exam is going to be, or what topics are going to be represented on the exam, and what portions. Oh, thank you so much. Thank you so much. I'm trying my best to help everyone not stress. And then on Canvas, I'll be posting once I have the exam more kind of codified. I'll be able to post a more precise thing. Like I'll be able to tell you 13.9% is this, and all that kind of stuff. But I will be able to give you somewhat of a breakdown today because I've kind of started organizing my thoughts. I'm in the trenches now, kind of writing specific problems. And then once I have all of them written, I'll know exactly what's up, and I will pass on that information to you. It is, okay, Winnie, it is totally possible. Whoops. Oh, let's see. The question as for element with electron configuration. Argon. Okay. Here, let me check. It's entirely possible. I mean, I did my best to proofread it, but it's totally possible that that we had some slip through the cracks. Here, let me finish working on this problem. I'll actually start pulling up Canvas. See if I can find that turd. All right, so this is our second structure. And the way you get a third, fourth, fifth, etc. is you just start riffing, right? You just start making variations. You can see that here with this one, we have 3 carbons on one side of the nitrogen, 1 carbon on the other. Well, what if we put nitrogen dead in the middle? This would give us a third structure. Right here would be a third one. That's my obnoxiously long password. All right. Now let's look at another way we could make a third one. Is what if we attach 3 carbons, or not a third one, our fourth one. What if we attach 3 carbons to our nitrogen? So what if we had carbon, carbon, carbon? Right. We still need to have 4 carbons total. But this would be a 4th possible structure. A 5th one would be possible. So you'll notice here, if I can go back to this structure, how we have a 3 carbon chain and it connects on the end. What if we had a 3 carbon chain, like carbon, 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 but instead of, well, hang on, that's a little crowded. What if we had the nitrogen connected to the middle? This would be a 5th structure. And again, that 5th structure is right there. So there would be 5 different examples. Okay, here, hang on. I'm going to log into, or I'm logged in. I'm going to pull up our quiz. Let's see if I can find this Argon turd. Oh, which electron has the following electron configuration? 4s2, 3d12. Okay, let me take a look at this guy. All right, and let's pull up a okay, so here. Let's pull up a periodic table. All right, so multiple choice exam. Whoops. No. Question. So, what elements? What elements has this electron configuration? All right, and the electron configuration given is we've got argon in a bracket, 4s2, 3d12. All right, let me just make sure that's what I have written down. Yeah, okay. All right, so let's find this guy. So we've got argon. All right, starting with argon. Then we drop down to 1, 2, 3, 4, right? 4s, 1, 2. And then we drop into the D block, right? We're dealing with 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. It just now took me realizing what the problem here was. The answer. Okay. Here's the problem. It's with the D count, right? There are 1, 2, 3, 4, 5 d orbitals. Am I right? Which means we can hold a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. D12 is not possible. All right. D12 is not possible. You guys are totally... Yeah, totally. Let's see. Let's fix this. I totally meant for this to be 3D10. Done. Okay, that means that... Here, let me pull up the spreadsheet. That means everybody's going to get a 2-point boost across the board for this problem. Let's see. All right, give me 1 second. Just want to make sure I make a note of this before before I move on and forget. All right, let's see. ADJ. Okay. Do, do, do. All right. That is in there. Okay. I'm going to cover all the chapters in the final, or are there any exceptions? Okay. Raj, before answering that question, everybody, just to let you know, I'm going to be giving everybody a 2-point boost on your Canvas grade. So whatever, because some people may have drawn this problem from the problem bank, some people may have not, because there was a typo and it wasn't answerable. The entire class is going to get +2 on their Canvas grade. So that will be reflected at some point. I made a note in my private grading spreadsheet, and when I upload, you'll probably see it reflected. You'll see it reflected when I upload the the scores for the written exam once I'm done grading them. So once I start going into grade entering mode, you'll see that reflected in your score. Okay, Raj, your question. Am I going to cover all the chapters in the final, or are there any exceptions? Heck yeah. Okay, let's see. Let me pull up. Yeah, so, okay. Raj, great question. The final is cumulative. There we go. Everything covered in lecture is fair game. All right, so everything we covered in lecture is fair game. Something you should know, though, is if there's material in the book that I did not cover, will not be on the final. So you don't have to, like, if you're like reviewing, you're reading the book, you're looking at stuff, and you're like, oh my gosh, we never talked about this. Do I need to learn this right now? The answer is no. If we didn't talk about it in lecture, then it will not be, it'll not be on the final exam. So hopefully that should prove comforting. So, Oh, let's see. Yeah, yeah, totally. So if you see something you don't recognize, don't freak out. It's not not fair game. You won't be tested on it. Um, one thing. So one thing that was interesting for me to see. I mean, so I'm a chemist, right? I like data. I like looking at data. I like interpreting data. It's fun for me, and there's this really interesting thing that happens where ever since we started. By the way, this is totally interruptible. This is me just talking because no one's asking questions right now. I will totally answer any questions that you have regarding the final, regarding the exam you just took, anything you want to see, anything you want to talk about. It's all fair game, and I'm 100% interruptible. I'm just talking right now because I don't have any active questions. But I don't know how many of you. I know there's a handful of you who have YouTube accounts, because I know about 60% of the views on our chem class are from subscriber, or not subscribers, are from subscribers, and then 40% isn't, and that 40% you don't need a YouTube account to watch YouTube videos, obviously. But those of you with YouTube accounts may be familiar with its analytical breakdown of viewership and stuff. Oh, any tips for the final? Let me think. Okay, okay, I can think of, I think I can, let me try speaking English. Yeah, here's some. So, let me think of, okay, so for a few final exam tips. Some, and these are general, these are good test taking tips. The first I would recommend is I would watch the clock. Right, it's going to be timed, it's going to be long. You don't want to sink a ton of time into Winnie, I totally can. And I will. Oops. You don't want to sink too much time into any one problem. Remember, you're going to have between 1.7 and 2 minutes per problem. So you don't want to waste a lot of time, because each problem is worth the same amount of points, right? So first thing I would say is watch the clock. Second, I recommend that you skip questions that you don't immediately know. All right. Skip problems that you don't immediately know. Remember, this is going to be a time crunch situation. So if you read a problem and you know, like, oh, I know how to do that one, do it right then. If you read it and you're like, I'm not exactly sure, I'd have to think about it, I could probably come up with something, but you don't immediately know it, skip it, right? You want to bang out every problem you immediately know. And I would move through the whole test like that. Skip all the problems you don't immediately know. Then it'll give you more time for the harder problems if you take care of all the easy ones first. All right. So it gives you maximum time for the hard problems. All right, so that's another really good strategy. Do all the ones that you immediately know, skip the ones you don't. That way then you can go back and work through at a slower pace. Even what I would do is, so I would burn through the exam, right, all the ones that were easy, and then I would look at the clock, see how much time is left, look at how many problems were left, and divide the time left by the problems, and you'll find that you have more than 2 minutes per problem if you do that, if you knock out all the easy ones first. Another tip is do not leave any blank answers. All right. If you see that you've got a minute left, don't leave anything blank. There's no penalty for guessing wrong, right? So if you've got 5 and there's a minute left, just go click, 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 click. Just guess something on each one. It'll give you a better chance to score higher, right? This is a standardized test. Taking standardized tests is a test in itself, all right? And part of that game is knowing the rules and knowing how to exploit them to the best of your ability. So those would be like general exam taking tips. And then I think the last one, the last tip, and this is more of a preparation tip, but review the topics you are rusty on. All right, now I'll be talking in a little bit about kind of my general breakdown, the topics that I know are making it on there, and roughly how many of each kind. And then as I get closer to having this thing finished, I'll be able to give you more specific information. But I'm going to give you a general list of topics today that says these are the topics that I'm pulling from for the exam, and if any of these are rusty, go back and review them, because you want to be able to bang out those problems quickly. Okay, let me see, Zulai. Okay. Okay, Zulai, great questions. Okay, so first off, we have no class next week. Next week is finals week, so there are no classes. There's only the exam. Second, that is my plan. I am attempting to make it about as hard as the ACS final. Using all my own questions, of course. Don't be sad. Okay, Winnie, you wanted me to do the hybridization of BRO2. Oh, yeah, this was cool. I'm going to miss all of you, to be honest. You guys have been an amazing Gen Chem class. Far and away the best Gen Chem class I've ever taught. And if you're thinking, oh, I bet he says that to all the Gen Chem classes, I don't, actually. I don't. I always strive to be truthful. So I'll tell a class that I enjoyed them a lot, or they were a great Gen Chem class. But you guys have been the best so far. Okay, so Winnie wants to see this problem. All right, so we're given the polyatomic ion bromite, which you don't need to know its name. To be able to do this problem. And we're asked to do a couple things. First, we're asked to... actually, I need to get myself a little more room. Let's scoot this thing over. And I have asked you to label the hybridization of this oxygen. And when you look at this oxygen, you may look at this oxygen and go, okay, well, we have one atom plus 3 lone pairs. That's 4 electron groups. And 4 electron groups means that we are sp3 hybridized. So just by looking at it, my best guess might be that this oxygen is sp3 hybridized. We're asked to do that in part A. Part B, we're told that there is a resonance structure we can draw for this molecule. So let's draw that thing. And the equivalent resonance structure looks like this. It's one in which this oxygen, the one that got the yellow pointy arrow, has a double bond to bromine. And the other oxygen has the negative charge. You can see that this one right here used to have the negative charge, but now it's double bonded, and the other one has the negative charge. All right, so that's the second equivalent resonance structure for this molecule. Then we're asked to draw 3-dimensional representations of the bonding orbitals between... Well, this says chlorine and oxygen when it should say bromine. There's chlorine. Just make sure. This okay. So in part C, we're asked to draw the 3-dimensional bonding orbitals between, well, it says chlorine and oxygen, but here we're dealing with bromine. So first, for this first resonance structure, we have between bromine and oxygen, we have a sigma bond. And then between the second bromine and oxygen, we have a sigma, but we also have a pi. To draw that pi bond, we need to show the p orbitals that are going to engage in indirect orbital overlap. All right, these will blur together to form the 2 lobes of the pi bond. All right, so that would be the bonding orbitals on the first resonance structure. Now drawing the second resonance structure. Again, we're still dealing with... Oh, that's a little ugly. I'm going to clean that up. 2 bromine, oxygen, sigma bonds. All right, but now on this, in this resonance structure, I should say, our pi bond is between the oxygen on the left and bromine. So we draw in our p orbitals. They blur together through indirect orbital overlap. To form our pi bond, I'm going to shade the bottom half, draw the electrons up top. All right, so these are the, this is the answer to part C. Draw the three-dimensional representation of the bonding orbitals between the bromine and the oxygen for each resonance structure. And we're asked to label each sigma and each pi bond. So on the left, our pi bond is is comprised of these 2 lobes. On the right, these are the lobes of the pi bond. On the left, we've got 2 sigma bonds, one here and one here. On the right, 2 sigma bonds are here and here. All right, so that's part C. Part D, in the second resonance structure, what must the hybridization be of the leftmost oxygen for a pi bond to be possible? Well, here, it's asking, in order for this oxygen to have a pi bond, what must its hybridization be? And the answer is sp2. All right, it's got to be sp2 if it has a pi bond, because if it was sp3, it wouldn't have an unhybridized p orbital, so it couldn't have a pi bond. Yes, on the right oxygen, correct. The hybridization of each, then part E, it says the hybridization of each atom is the same in all resonance structures. What is the hybridization? Oh, did I say the leftmost? No, the leftmost. Of the leftmost oxygen, that's correct. In the leftmost oxygen in the first resonance structure for the second one to be possible. And the answer is, it's got to be sp2, like this. Here, let me switch my colors up. This hybridization and this hybridization must be the same. All right, these 2 must be the same. So this is not sp3. It is actually sp2. So I was incorrect in my initial assessment. And then part F, based on my answers in part D and E, was my answer for part A correct or incorrect. For me, I wrote sp3. Turns out that was incorrect. And the reason why it was incorrect is because hybridization can't change throughout resonance structures. They have to all be the same. And in order to have a resonance structure with a pi bond, that oxygen must be sp2 hybridized. So my initial assessment of hybridization here was incorrect, is what I would have put. So anyways, that is the walkthrough on that problem. Okay, what about the lone pairs? Sorry, Winnie, I'm just seeing your question now. What about the lone pairs on the left resonance structure? So when are you talking about these lone pairs? Um, well, so it turns out the hybridization doesn't change. But I was asking about the leftmost oxygen, the one that we originally thought was sp3, but realized through the course of this problem was sp2. So the answer is let's see. Oh, okay, let's see. I'm at the 3D orbitals. The lone pairs on the 3D orbital. So in this one, here, hang on. So you don't mean this. So when in this problem, all of the lone pairs I've just drawn as dots. They're not actually a part of any of the orbitals. I know that like in some of them it looks like the lone pairs are up in an orbital, but they're just centered around an atom. I haven't actually drawn any three-dimensional orbitals for the lone pairs in this drawing. Is that what you were asking? Okay, let's see. Okay, waiting, I'm looking at yours. First picture you drew. Oh, okay, sorry. Winning, now I see what you're talking about. Okay, right. I just forgot to draw in my lone pairs. Yeah, that oxygen should have two lone pairs on it. Okay, Raj, looking at your question. How are they both sp2? One has more or less bonds. Okay. Raj, I'm going to open a new slide. All right, I'm going to open a new slide just to get everything kind of clean. And draw the two resonance structures. All All right, so we've got our two resonance structures here. All right, now, yep. All right. So, here's a couple things to remember. Remember these few things. The actual structure is a combination the fancy word for that is superposition. Of both resonance structures. All right, so it's both of these combined. The true structure is a combination of both of these resonance structures. In our first one, so I'm going to label this one, this is going to be resonance structure 1. This will be resonance structure 2. All right. In the first resonance structure, this oxygen has to be sp2 to make that pi bond. In the second structure, this oxygen must be sp2 hybridized for the same reason. All right, because it's got to make that pi bond. All right. Are you tracking with me so far? They both, in each resonance structure, they both need to be sp2 hybridized because they need that unhybridized p orbital to form that pi bond. Then with this last chunk of information, hybridization does not change between resonance structures. So the hybridization is the same in every resonance structure. All right, I'm actually going to change up my color scheme here real quick. All right, so since in the first resonance structure, that oxygen in green is sp2, that must mean that in the second resonance structure, if hybridization doesn't change, it must also be sp2 here. That blue oxygen in the second resonance structure is sp2 because it needs to make a pi bond. So that means that in the first resonance structure, since hybridization can't change between resonance structures, then it's also sp2 hybridized. Okay, let me see your comment. It stays sp2 in both. All right, so check this out. Check this out, Raj. On a new slide, I'm going to draw this picture, but using a three-dimensional representation of the bonding orbitals. All right, so track with me here. In the first one, we have our pi bond on bromine. Sorry, our unhybridized p orbital. That's going to. It's got one electron in it. It's going to make a pi bond with this oxygen. And if this oxygen on the end is sp2 hybridized, that means it's got 2 electrons sitting in that unhybridized p orbital. The pi bond here is between the bromine and the oxygen on the right. So it makes this pi bond. All right, and this is the resonance structure on the left. For the resonance structure on the right, what's going on? Again, both oxygens are sp2 hybridized. Oh, hang on. But for the resonance structure on the right, we're making a pi bond between the unhybridized oxygen that I've drawn its p orbital in green and the bromine in the center. So here's the picture of the two resonance structures. All right, so the thing is, okay, so first, for Raj's question, then Winnie, I'll get to yours. So so here's the deal. Electron domains determine hybridization when there's no resonance. When there are resonance structures, you have to take them all into account. To assign hybridization. So if you don't have any resonance going on, you just look at the electron domains. If you do, you're still looking at electron domains, but you have to look at the electron domains in every resonance structure, and then you pick the one with the lowest hybridization. So, like in this case, sp2. That is correct. Well, none of the at brush. None of the oxygens are sp3. Okay, Winnie, let me take a look at your... Okay, so you kind of get how one is sp3 and one is sp2. But if it's the best, why can't it be sp2? Okay, so Winnie, both of these are sp2, actually. They're both sp2. Because in this structure, it's got to be sp2 because of its pi bond. And in this structure, it's got to be sp2 because it must be the have the same hybridization in each structure. All right, and with this green one, it's got to be, again, sp2 because of the pi bond. And in this one, it's got to be sp2 to be the same in both resonance structures. Because your hybridization must be the same in both resonance structures. Does that make sense? Right. Okay, Raj, great observation. In the resonance structure, where the oxygen has 3 lone pairs, one of those lone pairs are in an unhybridized p orbital. One of those lone pairs is actually in an unhybridized p orbital. And if you look at it, between the lone pairs and bonds, there's 8 electrons around each one. It's just for one resonance structure, it's 3 lone pairs and 1 bond. In the other structure, it's 2 lone pairs and 2 bonds, right? 1 sigma and 1 pi, but it's 8 electrons no matter which way you look at it. That is correct, Raj. That is spot on. Spot on correct. Yes. Totally. That is exactly how you play that business. Heck yeah. Dude, you never have to apologize for that. That's literally why I'm here. My job is for when you're confused to help you get unconfused. So it ain't no thing. Totally. So are there any other questions out there? Any other questions? Or should I talk about final concepts? Yes, we can. Here, let's take a peek. Ooh, yeah. Oh, let's see. The 1,3 propyl diamine. Let me try to find it. Great minds think alike. All right. Okay, yeah. Here, let's check this out. Oh, okay, this one's cool. This one's cool. So, here, given a compound, oops, that looks like so. Right, 1,3 propyl diamine. It has 2 hydrogen bond donors and 2 acceptors in this structure. It's capable of forming an intramolecular bond, a hydrogen bond within one molecule. In part A, we're asked to draw an intermolecular bond between 2 molecules of 1,3 propyl diamine. So that is simple enough to do. You just need to draw another molecule of it. Which might be easier to say than do. Definitely faster to say than do because of all these stinking hydrogens. There we go. All right. So to do the intermolecular bond, it's between intermolecular hydrogen bond. We have the lone pairs on one nitrogen reaching out to the H on the other. This is the hydrogen bond donor because it brought the H. This is the hydrogen bond acceptor because it accepts the hydrogen that the donor is bringing. So we've got hydrogen bond donor, hydrogen bond acceptor. That is the intermolecular bond. And then we're asked to draw an intramolecular bond. All right, now there's a few different ways to do this, but the important thing that makes this different, intramolecular bond versus an inter, is we need to draw in an intramolecular bond, the hydrogen bond donor and acceptor are in the same molecule. All right. So to make this easiest, I'm going to draw it like this. You don't have to do this for it to be correct, but I just think it's a little easier if we draw the molecule in a different position. All right, so here is the hydrogen bond again. This lone pair grabbing this hydrogen. This part of the molecule is the donor. And this part of the molecule is the hydrogen bond acceptor. Okay, Diana, great question. Okay, when we were talking about hydrogen bond donor acceptor, is it the whole molecule or just the adjacent atoms? So for you could honestly look at it either way. You could say that the adjacent atom is donating the hydrogen into the hydrogen bond, or you could say this whole molecule is acting as both the donor and acceptor. So Diana, oh hey, no worries being late. So Diana, both can be correct, depending on your perspective. You could look at the entire molecule as being both donor and acceptor, or you could say this specific nitrogen is acting as the donor and this specific nitrogen is acting as the acceptor. Both would be correct ways of describing or looking at it. Also, fun fact, so Diana and everybody else who was there in lecture, you might remember when Diana asked about inter and intramolecular hydrogen bonds. I had already written this problem when she asked that question, and I was not planning on talking about it at all in lecture. This was going to be like one of the surprise problems that like pushed you a step beyond. I was not planning on talking about inter versus intra, and then she asked about it, and I was like, dang it, but I got to answer the question. So so for those of you who are helped by that section of the video, you can thank her for asking the question, because I was gonna leave you alone in the dark, and that question shone a light on what was already on the exam. It was a total spoiler. Total spoiler. But in the best possible sense. Let's see. Would it be incorrect to draw the intermolecular bond interbonding with both parts? Sule, are you asking about yeah. That is not wrong at all. That is totally correct. Even if you only drew one hydrogen bond, that's fine too, but if you drew both of them bonding, then they're both totally fine. Yeah. Yeah. They're definitely different versions. Raj, you had one with oxygens in play. Totally fine. Yeah. Totally. I'm sensing you might be somewhat high stress when it comes to class stuff. You're doing totally fine. Let's see. Alrighty. So what are there other questions out there? Or do you want me to talk about topics for the final that you may be running into? Let's see. So when you have intermolecular bonding happening... Oh, Diana, that is a great question. So what happens is the molecules clump together and move around as this big blob. So another great question. Actually, the geometry isn't changed because both the donor and acceptor both the donor and acceptor still have the same number of electron groups. So the geometries won't morph because the number of electron groups around each atom hasn't changed. Okay, let me pull up kind of a rough, totally. Okay, hang on. I'm just getting a So I'm looking up the rough points breakdown that I have so far for the final. Okay. All right. So here's okay, so on the final oops. Whoa. I just painted my whole screen black. You'll see it in just a second. So final exam topics. I gotta admit, I finished writing our exam 3 Canvas, then take home, and then I wrote a take home lab exam for my OChem class, and then I sat down to write, start working on our final exam, and this is can be quite a challenge, because the final exam's cumulative. There's a lot we've talked about this semester, and so finding kind of there's a lot of stuff up in here, but I kind of have a so I have a cluster of topics. What I don't have is I don't know precisely how heavily each topic is going to be represented. So what I'm about to give you is the list of topics that you can study for, but I do not, as of yet, know what... Whoa! How cool is that? How cool is Professor Green? The answer is so cool. And if you doubt me, just check this out. He shares a last name as the lead singer. Whoa, the lead singer. For Circus Survive. That's how cool he is. Let's see. Oh, wow. Well, people really don't want to take a final. But here's the problem, though. Is if there's no final, then you all are missing out on a huge chance to pull your grade up, right? If there's no final, then your fate is sealed. But if there is a final, you can score higher than your current averages and lift things up. You know what I'm saying? Oh man. Here's the problem. There's one problem with that. As it turns out, I'm not that cool. Optional final. That sounds like garbage. Like, if I'm gonna do all the work to write it, then sure as heck you guys are going to do all the work to do it. Because if I write a final and then make it optional, no one will take it. What the final can hurt. That is true, Vraj. The final can hurt. It can. But the biggest monster drops the most loot, right? The biggest monster drops the most loot. So your final exam is your moment of glory, your chance for glory, or a sudden fall. And it's up to you to decide your own fate. So we totally are having a final. Take a. Are you sure you don't take bribes? I don't. Sadly, I don't. Sadly, I don't take bribes or breaks. No, we're totally doing a final. Like, totally doing a final. Yes. No. The Joker wants your glory. The Joker wants your glory. I'm giving you a moment to shine. And when you think about it, I realize not everybody's going to med school. Right? Not everyone's taking Gen Chem to be a doctor or a dentist or a veterinarian or whatever. But if you are, you're going to have to take the MCAT or the DCAT or some such a standardized exam. This is the pilot episode for that future moment. This is that thing that's going to help you get there and do well. Because your ultimate goal isn't a high grade in this class. Your ultimate goal, for most of you at least, is to be a doctor, to be a dentist, to be a veterinarian. And taking this final will help prepare you for that exam that is going to get you to where you actually want to go. So I'm not just doing it because I'm evil, though I'm mostly doing it because I know that you, Batman, need to get through this to succeed in your rise to become the Dark Knight. The Good Dinosaur. Dude, I don't know if you've seen that movie, The Good Dinosaur, but the dinosaur and the little friend that he finds totally trip on shrooms. And I was watching that with my kid when he was like 6. And he's like, what's going on? Why are they so giggly? So thank you, Disney Pixar, for introducing hallucinogenic psychotropic drugs into my kid's consciousness. No, Sulai, don't be homeless. Oh man, I'm falling behind on... Okay, do I round final grades? Okay, so so here's the deal. It's not in the syllabus. Farming is not a bad not a bad call. It's actually kind of cool, but you know. Okay, so here's how rounding works. Works for final grades. I round everything to the ones place. So, a 69.5 rounds to 70, which equals a C. 69.4 rounds to 69, which equals a D. So Sulai, to answer your question, 89.9. Oh yeah, totally. Winnie, it does. 89.49 rounds to 89, which equals a B. Everything rounds to the ones place. And yeah, so so yes, totally. So that's how rounding works. Press F. Oh my gosh, that is the best. Oh man, I love that. Okay, why don't we talk about topics, things that that you might run into on the final exam, which I'm totally writing and you all will totally take. Well, you don't have to take it, but if you don't, you'll get a 0. So I recommend it. All right, so let's see here. So topics. Isotopes. Oh, not isotopes. Isotopes be there. Definitely you'll be running into some good old stoichiometry. Let's see. Mass percents. Something that's kind of old. Light. Quantum. Electron configurations. Can totally show up. Periodic trends. Let's see. Lewis structures. Vesper. Intermolecular forces. Oh, I'm not going to write that out because it's going to take way too long. We'll just go IMF for intermolecular forces. Whoa. Okay, hang on. Aliens are trying to communicate with me through Photoshop again. There we go. We can have hybridization. Sigma / pi bond stuff. Acid base. How about that? Gas laws. Wow, I bet gas laws will be on there. Ooh, redox. And wait for it. Thermochem. We haven't thought about thermochem for so long. Ah, okay. Yes, yeah. There will be about 60 to 70 questions. I'm not sure exactly how much, but in between 60 and 70 questions. The beginning of the video has some final info. Let's see. When you're looking for just the right emoji. There we go. How far do the calculations go on the exam? Winnie, great question. You will have 110 minutes. Okay, Winnie, let's see. The final exam questions are based on the ACS homework. So the calculations will be as lengthy as the homework calculations. So the homework is really the approximation of what you're going to be seeing. Now, as far, so I don't have specific breakdowns for you yet as far as like what percentage of what can we expect for the what. I will have those later and I will be posting those. But I don't have exact stuff for now. I do have some of them are totally. So again, the percentage, the percentages I'm about to put down are rough approximates. Okay, so I'll have more precise information about this in the future, but oh yeah, no, the current stuff is in there. You can definitely see, but I would expect around, whoa, there we go. Maybe like about 25-ish% of it will be based in stoichiometry. So that one's going to be very heavily represented. For everything else, you can expect. See, I'm like looking at kind of my. We did go over so much. This semester was so long. Really, for everything else that isn't stoichiometry, you can expect somewhere between 4 to 10%. Again, the specifics, I'll have more information. But it's going to be, all of them will be in that ballpark, but you can definitely bank on stoichiometry representing a fifth to a quarter of the final exam. Oh, hold up. There's a topic I forgot to write down. Don't forget naming. You will totally be tested on naming for this thing. Dude, it seriously does. Oops. It feels so long ago, like a lifetime ago. think it's because of everything that's happened, everything we've been through. It's weird to think that that at one point we were like just going to class and like normal kids, and yeah, naming. There's problems on there where like I ask you to name stuff and then give you 5 different possible answers, and you got to pick which one's correct for ionic compounds or covalent compounds or you know, acids, all that stuff. So oh, snap. Is that even on here? Let me see. You know what? You know what I'm going to do? Cuz yeah, solubility rules are in here. I'm going to add one last category and call it I'm going to call this last category miscellaneous. Maybe we'll say like 10 to 15 is miscellaneous. So yeah. This whole thing has been stranger than fiction, which, by the way, Stranger Than Fiction is an excellent movie. You should definitely watch it. So for the miscellaneous catch-all, this could include like ionic equations, solubility, all sorts of good stuff. Yeah, it is a great movie. How do we study for miscellaneous? Winnie, that is a great question. Great question. I am the reason I mean essentially you can't study for miscellaneous, right? Solubility, electrolytes. You can't study for miscellaneous. The reason I added a miscellaneous category is in case there was something I forgot to mention. I didn't want anybody to say like, well, you didn't say that you were going to test us on net ionic equations. When I had, I just in my defense at this moment in time, on the spreadsheet where I have brainstorm problems for ideas, I have all those headings that I wrote, and then I do have a miscellaneous heading, just for things that didn't have enough problems under that category to represent 4 to 10% of the exam. But Winnie, also you should know that yes, study everything. Study everything that we covered in lecture. But also, I will write a canvas announcement with all topics written out. So right now, it's the only reason why I'm vague is because I'm at the relative beginning of writing this thing, so I don't know exactly what's made it onto the final version of the exam, but I will post a Canvas announcement with everything. Every topic that makes it onto the exam will be represented with the percentage of the points associated with that problem type. So you will get more information in the Canvas exam. I'm trying to be as specific as I can now, but I haven't finished it, so I don't know exactly how it'll go down. Does that make sense? So this is the best kind of approximation that I have at the moment, but you'll be getting more information later. I hope to be posting that thing around tomorrow is when I'm hoping to do it. Totally. All right. Real quick, I'm just gonna check. I'm gonna check just in case someone emailed a question into office hours. All right, no, we're good. Totally. So, are there any other questions out there? Alrighty, well, if there aren't any more questions, then I will go ahead and call our office hours here. I mostly just want to say a big fat thank you to you were all the Rona class of 2020. I have this has been a challenge from a technical standpoint to teach this semester, but I have to tell you that you have all made it an absolute pleasure. Thank you so much for engaging and hanging in there with me through the semester, helping me to improve as a teacher. Your feedback has been excellent and constructive and positive, and you've let me know in a kind way when I'm not doing things super well, and it's helped me improve. I can't thank you enough. I think you guys are all stinking rad. It has totally been my pleasure to teach with you all and learn with you all. Whoa, maybe I can learn to spell one of these days. And I know that one of these days they'll start holding class back on campus again, and maybe we can bump into each other there, and actually, I don't know, give each other a high five and not have to worry about social distancing. Winnie, great question. Whoa. So at this point in time, I'm trying to get the final written. Once that's done, I'll sit down with I'll start grading the exams. And so I don't know exactly when I'll have the final completely finished. But once I do, then I'll jump to grading exam 3, and we'll see how this goes. Heck yeah! That is awesome. It'll be the Rona 400 after party. Okay, Raj, you asked the question. Oh, who's the best student in the class? My fave. Oh, Raj. You are all my favorite students. The parenting tip number 1, first rule of parenting: there are no favorite children, or everyone's your favorite child. And it goes the same for teaching. Everybody's the favorite student. I can definitely. I'm gonna miss you guys a ton. I mean, I'm teaching over the summer, so I'll be doing. It's a 305. It's a 305 class, so it's the non-majors chem class, the one I'm teaching over the summer. But but I feel like what we had was special. Like that class, it'll be 100% online. Like we'll never actually physically meet. And I'm gonna try a couple different things for connecting. Like I'm gonna add a little like webcam so they can at least know what I look like. Um, but I'll never actually have like met them in person. We're gonna go a whole summer. They're gonna finish the class, graduate, and I won't have met them. Like you will be the only class where we started in person and then went to purely online. So even though we, are like chatting. Raj, just because I love everyone doesn't mean everyone's getting an A. But everybody who does earn an A, I will totally give you a letter of recommendation. If you earn it, I will write it. But yeah, so yeah, like you guys are a unique class because we had all these interactions, YouTube live chats, messaging over Canvas, all that stuff. But it starts with we started with that face to face, so we had that rapport, and then we went online. My online classes from here on out will be 100% online. Winnie, my letter writing policy, for Raj asked me about this earlier this semester. My policy for writing letters of recommendation is, I don't know whether or not I'll write someone a letter of recommendation till the end of the semester, because my policy for letter writing is if you earn an A in the class, then I will write a letter of recommendation. So that is that's that. So I don't know whether or not I can write anyone a letter until final grades have been assigned. So he was just referencing that earlier point in time. All right, let's see here. I need to check on. Dude, we've been rocking for 2.5 hours. It's like we don't want class to stop. Oh, but I actually think it needs to now. I just checked on my my almost 2-year-old, and looks like he is up from his nap. So this is where I'm going to have to say goodbye, and it actually makes me super sad. But before I do, let me give you one last song of the day. One last song of the day. If you when it starts sinking in that, oh, it's over and we're missing each other, and all of that starts coming down, check out When the Music's Over by The Doors. It is the last song of the day, and this is our last stream of this utterly unique semester. Thank you all for making it memorable. I'm going to miss the heck out of all of you. This channel will continue streaming over the summer. So if you're feeling nostalgic, or maybe you need a little MCAT review, you can pop in and see what we're talking about. It'll also continue streaming over the fall. And again, if you, I guess I could say this, if you want to go back and find the specific videos from our class, there's a playlist on the channel that's Chem 400 lectures, and then there's another playlist that's Chem 400 office hours, and it's those playlists, video playlists, have been constructed chronologically, so you can go back and look at what lectures were when, if you need those for resources in the future. Totally. So those will be available. I'm not going to take those down. You'll be able to find them here anytime in the future that you need them, and totally feel free to eavesdrop on any future classes. It would make me smile to see your faces pop up in the live chat. Anyways, thank you all so stinking much. I'm gonna go get my 2-year-old up, and then after I put him back to bed, keep working on our final. You keep grinding away, and yeah, I hope to see you in the future, not just electronically, but hopefully in person as well. Take care, guys. Good luck next week. I'm rooting for each and every one of you. Later. Heck yeah.